Hello everyone. In today's lecture, we will discuss another new concept in terms of the transient state stability. That's called as multi-machine problem. That how that multi-machine problem should be affected on the stability of the transient under the transient state. Because in terms of that single machine system or the multi-machine system, the main difference is nothing but what the stability analysis under the multi-machine system that should be connected in the parallel under the synchronizer at a synchronous speed, their synchronization and their the stability maintenance to maintain their stability. It's a very difficult task as compared to the single machine that is connected to the infinite bus. Okay, so let us discuss the multi-machine problem that should be directly how that problem should be correlated with the transient state stability. Okay, so in terms of that multi-machine system, as we all know, the equal area criteria are generally is only applicable. It cannot be directly applicable to what multi-machine system. It only applicable to what it's only used for that say one or the two machine that are connected in the parallel. That's why that equal area criteria must be applicable to the single machine connected to the infinite bus or the two machine or the not more than two machine that should be connected to the infinite bus. So here the equal area criteria, that's why it is not directly applicable to the system where the three or the four machines should be connected. Thus the con- uh, complication of the in the numerical computation increases where the with the number of the machines should be considered in the transient stability studies, because the equal area criteria is nothing but all it's used to identify the graphical representation to graphical analysis of that stability transient state stability का graphical analysis purpose है उसके लिए equal area criteria use होता है. But अगर whenever there is a more than two machines should be connected in the connected to the infinite bus, then the then complication numerical computations should be studied but very complicated as the number of machines should be connected to the infinite bus. Thus, the system complexity of the system voltage, computation burden, the following assumptions are generally made while analyzing the multi-machine system for that transient stability. Number one, mechanical output, mechanical power input to the each machine should be considered is nothing but a constant. Means और सभी का mechanical input क्या चाहिए constant. Okay. Second, the damping power is nothing but the negligible. Damping power is nothing but the negligible. The damping must be there, then the inertia affect होगा. Inertia affect होगा तो automatically their synchronous speed should be the affected. Synchronous speed should be affected, and the stability should be directly affected. Number third, the each machine must be represented as a constant transient reactance. अगर transient reactance अगर of the each machine is not should be the kept is at a constant with a constant terminal voltage, then it's directly applicate the power output of that concerned machine. Means what the input of that concerned machine of the every machine that are connected to the multi-machine system, each machine that are connected in the multi-machine system, their input power must be constant and their output power must be constant, so that to maintain their it is more easy to understand to analyze the stability of that different machine system. So thus this system stability model based on this assumption are generally called as classical stability model, and that study is called as classical stability studies. Okay. So consequently, in the multi-machine system, the two case steps are generally required to analyze the transient state stability. Number one, the steady state pre-fault condition and the pre-fault network representation in account to the fault and for the post-fault condition. So the pre-fault condition and the post-fault condition का analysis multi-phase condition के इसमें two case step में किया जाता है. Number one, steady state pre-fault calculation that generally calculated by the using the production type power flow diagram. Power flow diagram का use करके pre-fault condition निकाल लेंगे. And second, by using the determined pre-fault network representation is determined, then the modified account of that fault and for the post-fault condition is generally calculated for the multi-machine system. Number second, the transient internal voltage of the each machine is should be then calculated by using the equation E is equal to Vt plus J XT dash into the I, whereas Vt is nothing but what corresponding terminal voltage, I is nothing but output current, and that Xd is nothing but the transient reactance of that concerned transmission multi-machine system. Under the each load should be connected into the constant admittance to the ground at its bus using the Z should be converted into the admittance is equal to the PL minus JQR upon is nothing but the one mode of V square, that is a terminal voltage. This is for the multi-machine transient condition, multi-machine problem with respect to the transient state stability. So this is nothing but the augmented network or the this is generally network are generally used where the more than three machines are generally connected to the transmission system. That is nothing but 1 2 3 having the internal terminal voltage is nothing but E1 E2 and the E3, and their output is nothing but what it generally the output should be the same, whereas this is YLS YL4 and the YL5, that is nothing but that is the admittance of that concerned transmission network. Okay, so where the load and the VL is nothing but the magnitude of the corresponding bus voltage, and the bus admittance matrix, that is a bus we're using, which is used for the pre-fault power flow calculation, is now is nothing but what? It's an augmented matrix that include the transient reactance, terminal voltage, and the shunt admittance of the each load. So in the secondary steps, this matrix is modified corresponding to the post fault and during and after the fault power flow into the network for the each generator calculated by corresponding power flow angle equation. So basically, in terms of that multi-machine system, to analyze or to identify the transient state stability, the two cases are generally carried out. It should be the stability should be calculated by following the two steps. Number one, स्टेडी स्टेट प्री फॉल कंडीशन में अपन कैलकुलेट कर लेंगे सिस्टम पावर आउटपुट अंडर द प्री फॉल कंडीशन बाय यूजिंग द पावर फ्लो डायग्राम. नंबर सेकेंड, बाय यूजिंग द पोस्ट फॉल कंडीशन में अपन उसका कैलकुलेट करोगे. ये दोनों कंडीशन में कैलकुलेट करके व्हाट शुड बी द डिफरेंसेस देयर दैट जनरली एनालाइज विद रिस्पेक्ट टू ट्रांसिएंट स्टेट स्टेबिलिटी ऑफ दैट मल्टी मशीन सिस्टम. So the analysis and the calculation with respect to the multi-machine system transient stability of that multi-machine system is very difficult as compared to the as compared to the two machine or the single machine that are connected to the infinite bus. Okay, that's why that more advanced meter are generally required to analyze the stability of the multi-machine system, that is more than 3 to 4 machines that are connected to the system. Okay, thank you so much. In next lecture, we will discuss another new concept with respect to the transient state stability.